What happens when a robust material such as metal meets with an innovative technology? The answer is a revolution in manufacturing. Today, the technology is used in sectors such as healthcare, aeronautics, industrial goods and tooling, eyewear, and more. Let's take a look at how it works. Metal 3D printing is a laser-based technology that uses powdered metals. Similar to laser sintering, a high-powered laser selectively binds metal particles on the powder bed. Support structures are required for metal printing. These are automatically generated and built simultaneously in the same material. Once the part is built, it then undergoes heat treatment to strengthen it. After this, the parts are removed from the base plate, and the final step is to remove the support structures. Components fresh off the printer typically have a rough surface finish, and there are various finishing degrees to choose from that will allow you to achieve smooth, matte, satin, shiny, or reflective surfaces. In addition to surface finishing, parts can be post-machined to create threads, boreholes, or fine surface details. With the combined strengths of the material and technology, Metal AM has emerged as a cutting-edge option for any application that involves complex metal parts. For instance, for medical applications, the technology can enable personalized implants and enhance the design of medical devices. Materials used for metal 3D printing include aluminum, titanium, stainless steel, and Inconel. Each option has its own unique qualities ranging from strength and thermal properties to mechanical properties to corrosion resistance and more. When you start designing for metal 3D printing, there are a few key points to keep in mind. 1. During production, the melting and cooling of powder can result in thermally induced stresses. In order to avoid construction errors or warping, it's important to take the process-specific restrictions into account when you're designing the part. So, for instance, corners should be chamfered and rounded rather than sharp. 2. The minimum required wall thickness is generally only 0.5 or 1 millimeter, but it's a good approach to go for 2 millimeters for structural walls and elements. 3. To make post-production easier, you can minimize the contact area between support structures and the component. This makes it easier to remove the supports and any residues on the component surface. We've seen that metal 3D printing holds a unique position in modern-day product development. So to sum it up, we can say that metal 3D printing enables the direct manufacturing of complex end-use parts and facilitates tooling for conventional manufacturing technologies.